In this video, I'm going to show you how to use calculus to do questions that relate to displacement, velocity, and acceleration. Our first question, you're given a position equation in centimeters, and this position is of an object on a horizontal line, and t is going to be time in seconds. And we're trying to find out everything we can about t equals 2 seconds. On the side over here, we have a summary about displacement. So in this case, we have x of t's displacement is going to be in centimeters for us. Velocity would be the derivative of the displacement. Acceleration would be the second derivative of displacement. So first of all, we're going to use the original displacement or position equation and plug 2 into it, and we get this value. Because we get a negative value, the position is left of the origin or the reference point, specifically 12.8 centimeters from that origin. Next, we're going to do the derivative of the displacement, which gives us velocity equation, and we plug in 2 into that, and we get this value. The velocity sign gives us the direction of movement. The object is moving to the left because this is a negative value. And the speed without the direction is just 15.5. So the negative gives you the direction, and this number gives you the magnitude. Now we can do the second derivative of the position graph or equation, or we can do the first derivative of the velocity to get the acceleration. Then we plug in 2 and we get this value. And the meaning of this value is the following. The acceleration sign, the negative, gives the direction of the acceleration. So the object is accelerating left, in the left direction at 8.1 centimeters per second squared. Now, because we have movement in the left direction and acceleration in the left direction, both are going in the same direction, so this actually is implying that object is speeding up. So please do not make the mistake of seeing a negative acceleration and assume that it's going to be slowing down, because it might not. It all depends on the direction it travels as well. In this question, we're going to just practice a little bit more how to figure out whether something is slowing down, speeding up. And here, there's many ways to approach these types of questions. But what I'm going to show you is how to concentrate on using only the following information about the derivative and second derivative and its signs and what it implies. So in these questions, whenever you see the word acceleration, think second derivative. When you see velocity, think first derivative. When you see just speed, I'd like you to think of it just looking at the steepness or just magnitude of the slope as you're looking from left to right of this graph. So part A, if velocity is negative, so here's the derivative less than 0, and acceleration is positive, so second derivative is greater than 0, then we need to find out what's happening with the speed, whether it's slowing down or speeding up. So this first part tells you that the first derivative is negative. So first derivative being negative means the original function was decreasing. So that's what I wrote down. And second derivative being positive, so second derivative is positive, that means the original function is concave up. So just draw a graph that's concave up. And the fact that it's decreasing, you're going to only think about this yellow portion right here. Next, draw a couple of tangent lines to look at the slope. So first, in this position, the slope is steep, so speed is fast compared to this one. Slope is flatter. So in other words, we are slowing down. Next, B. B says if velocity is positive, so we have first derivative is greater than 0, which implies, first derivative positive implies the function is increasing. We're also told that the speed is decreasing, so that means slopes will be getting flatter. our question is to find out whether the acceleration is going to be positive or negative. So, because the function is increasing, it could increase in this way, or it could rise up this way. Let's look at the slopes of tangent lines. So here, the progression from left to right, slopes are getting flatter. Here, slopes are getting steeper. So the one that we want is the one that slopes are getting flatter because speed is supposed to be decreasing. And you could see from this graph that it's concave down, and concave down implies acceleration will be negative. All right, question C. If velocity is positive, so the derivative is greater than 0, and decreasing, so the first derivative is decreasing, the question is, we want to know what's happening with the speed. Is it slowing down or is it speeding up? So let's start. So the first derivative decreasing means the second derivative is negative, which implies that the original function f is concave down. On this part, we have first derivative is greater than 0. That means the function was increasing. So if you were to draw a concave down graph and concentrate on the part where f is increasing, and then look at just the slopes of the tangent lines and ask yourself, as you're going from left to right, are slopes getting steeper or flatter? They are getting flatter, and so we are slowing down. On to D. If speed is increasing, that means in terms of slopes, they're getting steeper. And acceleration is negative, so second derivative is below 0. We want to know, is velocity positive or negative? So second derivative being negative means the function is concave down, so you just draw concave down. And we have all these slope tangent lines drawn in. We want to pick the place where we have slopes getting steeper. Getting steeper would be this portion. So in this situation, the function is decreasing, which means slopes are negative. And so we would say velocity is negative. Question E. If velocity is negative and increasing, we want to know what's happening to the speed. Are we slowing down or speeding up? So remember, velocity is always going to be your first derivative. And so you're told it's negative, so first derivative is negative. And velocity is increasing, so first derivative is increasing. Now, first derivative increasing, what does that mean? That means that we have concave up original graph, or you could say the second derivative is positive, which regardless is going to apply concave up. So you draw concave up. Now this part, the first derivative being negative, so first derivative is negative, that means the original function was decreasing. So if you highlight that part, you will see this portion of the graph is the only thing that makes sense here. Then, because the question is about just speed, we're looking only on magnitudes of the slope. And as we're going from left to right, slopes are getting flatter, and that means we are slowing down. Final question, F. If the particle is moving left, so moving left implies that velocity is negative, so first derivative is negative. Then we're told speed is decreasing. That means slopes are getting flatter from left to right. We want to find out what is acceleration. Is it positive or negative? So, because we are trying to find out slopes getting flatter and flatter, well, here they're getting flatter and flatter, or here they're also getting flatter and flatter. However, the first derivative being negative, we know first derivative negative implies the original function is decreasing. And the only part that's decreasing is this one, because that one's rising from left to right. Now, this portion here that we highlighted is concave up, so acceleration must be positive.